Yeah, so SQL encryption, always encrypted. We're gonna talk about always encrypted. Previously, we talked about encryption hierarchy, and then we take a deeper look at transparent data encryption, how it works, what the things that you need, and when do you use TDE. And then after that, we talked about cell level encryption, wherein you can encrypt column level data for your tables and data for the tables in your database. So after that, on the last slide, we talked about what's next. So the next thing that we're going to talk about is always encrypted. And then if we have time, we're going to talk about always encrypted secure enclave. I put an asterisk there. I'll talk about it later on why I put an asterisk on secure enclave. So we'll go into details later on. Let's first start. Before we start, I would like to introduce myself. There was a comment on the evaluation that I didn't introduce myself on all the sessions. So yeah, I'm Pio Balistoy. I'm a lead Microsoft Data Platform Consultant for PTN. I'm a Microsoft Data Platform MVP. I'm also all those logos on the left side. I am one of your organizer for SQL PASS Singapore. I also administer the Philippine Data Platform Forum for the SQL Server User Group Community for Philippines. If you want to reach out to me, if you want to talk about data, you want to ask anything about SQL Server, you can reach out to me through all those channels. I've been managing database since 6.5, since SQL Server 6.5 up to Azure SQL. So I've done all of the versions of SQL Server. If you have any questions, just reach out to me. So yeah, so enough about me. We're here to talk about Always Encrypted. So what's Always Encrypted? Always Encrypted was introduced at around SQL Server 2016. At first, it was an enterprise feature, but then when they came out with SP1, it became available for all edition. So Always Encrypted is encryption in flight and at rest. What does it mean? Remember we talked about TDE, wherein your data is encrypted at rest because it's stored when it is encrypted at the storage level. For Always Encrypted, the data is encrypted when in the storage and also while being transmitted between your client and your SQL server. So the encryption and decryption happens on the client side, not on the SQL Server engine. This is trying to address a very common issue. Ever since, even before Always Encrypted came out, one of the concerns is when you have a database administrator or database operator, they usually have complete access to your data. Even for example, if you have cell level encryption, your database admin can see the data in plain text. He has a way to see the data. So it's a privacy concern, for example, especially right now during the cloud era, wherein your database is hosted on an outside provider. So there are different database operators working on your database that are essentially not part of your company. So it is a big privacy concern, right? So Always Encrypted allows you to separate the role between the database administrators and database operators, and to those users who are supposed to see the data. So your data is only visible to your application through your application. It won't be the plain text information won't be available for your high privileged users like your database administrators. So the DBA cannot access your data. And Always Encrypted, we'll gonna talk about how Always Encrypted implements this scenario. So in terms of encryption mechanism for Always Encrypted, you have two types of keys, column master key and column encryption key. Your column master key resides outside your database. It's on a separate location. So only those that requires permission for the master key has access to the master key. It's not stored on your database server or in your database engine. Column encryption key, on the other hand, is stored on your database engine. It is used to encrypt your data. Column master key encrypts your column encryption key, and column encryption key encrypts your data. There's two types of encryption for Always Encrypted. The first one is randomized, wherein the ciphertext for your data is always different, regardless if you're encrypting the same information. For example, you're encrypting hello world. For randomized, the ciphertext for hello world will always be different. For deterministic, the ciphertext for your plain text information will be the same. It's still encrypted, but the ciphertext for the same words or the same information is the same. The different that's the main difference between the two. The advantage on that is for deterministic, you can create indexes on the column, because the values are, as the word it says, they can determine the value for it. So you can do simple equality operations on deterministic, but for randomized you can't. And in terms of algorithm, there's only one right now. That's the algorithm that we use for Always Encrypted. And then let's take a look at how Always Encrypted works. So first you have your database, and you have your data inside your database. So like I said earlier, when you want to use Always Encrypted, what you need to have a column master key. Your column master key is not saved within your server. It is saved in your key store on a separate environment than your database engine. You can use a Windows Certificate Store, an Azure Key Vault, or if you want to use a third-party provider, you can use a key storage provider. But your key storage provider needs to have the same. It needs to be able to talk to the client drivers for Always Encrypted. So you have your column master key, and then you create your column encryption key. Your column encryption key resides on your database. This will be used to encrypt your data. You use the column master key to encrypt your column encryption key, and then in turn, the column encryption key encrypts your data. So that's how the two keys work and how your data is encrypted. If you look at it from the application perspective, you have your application here. The encryption happens on the client driver. Like we said, the encryption for Always Encrypted happens on your application side. So you have it needs a specific client driver that has the Always Encrypted capability. So, for example, you're sending data to your SQL server. Your data on the application side is plain text. Your client driver contacts your key vault, checks on the master key, use it to decrypt and the encryption key from the database, put it on the client driver, and then encrypt this plain text data. After it encrypts the data, it will send the data to your SQL server. So your SQL server engine will only see the ciphertext. It will never see the plain text data, because it's already encrypted before it is sent to your SQL server. That's why it's Always Encrypted. So it's encrypted in flight and at rest. So the data goes through the network already encrypted, and then it's stored on your database encrypted. So like this. So what you see on your database is the encrypted value. There's no way for you to see the unencrypted value. If you want to view the unencrypted value, for example, you query your database, what happens is the SQL server sends the data, the encrypted data, the ciphertext, to your application. The client driver on your application side is the one that will decrypt the ciphertext and then display the data for your application in plain text. So all the decryption and encryption happens on the client driver. It's not happening on your SQL server. That's why it's separated. So only the the users that require access to your plain text data can view your data, not on the engine. The downside on that is you cannot do any uh, computation or any comparison for the data on the SQL Server side because it doesn't have any capability to decrypt and encrypt your data. So if you are going to manipulate your data, for example, you need to do some computations, you need to do some joins or you need to manipulate your data. You need to get the data out first from the SQL Server, get it to your application, and do your computation on the application layer, not on the database. So let's just compare quickly the three items that we have already discussed. So TDE, the encryption happens on the storage level. For cell encryption and for cell encryption, the cell level encryption, the encryption happens on your database engine. For always encrypted, it's the encryption and decryption happens on your client side. So is it encrypted at rest? For all of them, it's yes. Is it encrypted in transit? For TDE and cell level? No, because you decrypt, even for cell level, you decrypt on the database engine. For TDE, once your data is loaded to the buffer pool, it's already decrypted. It's only encrypted on the storage level. So it's not going to be encrypted in transit when you query your data. The only way to encrypt in transit for TDE and cell level encryption is to use SSL together with it. Role separation. So for TDE and cell level encryption, there's no real role separation. Your database administrator will always have the ability and the permission to decrypt your data. For always encrypted, there is a role separation because your master key is not stored on your database. So if you don't want your database admin to decrypt your data, if you don't want him to have access to your plain text data, don't give him the permission to access your master key. Schema changes required. For TTE, there's no schema changes required. For cell level encryption, there is schema changes. You need to change the column itself. And then for always encrypted, well, on the documentation, it's going to say there's no changes required. Well, but I'm going to show you later on why I put an asterisk on that. Does it require any specific client drivers? For TD, it's not. There's no specific requirement. From the name itself, it's transparent to your user. So there's no need. There's no changes on the application side. For cell level encryption, there's no specific driver for it because the decryption and encryption happen on your database engine. For always encrypted, there is a specific requirement for client drivers. There are a number of drivers available out there that allows always encrypted. For example, for .NET Framework 4.5, I think, allows always encrypted, as well as there are some ODBC that allows AE. So if you're gonna use AE, you need that on your client side, on your application. So enough talk. Let's take a look at how it works and how we can set up AE. There's a question. There's a question on the chat. Does this also protect the data when in backup and when restoring the data to another server? How is this related to TDE? So as I mentioned earlier, your data on the data is stored encrypted. So it's the ciphertext that is stored on your database. There's no way for anyone to unencrypt that without the client, one, without the client driver, and two, without access to the master key. So does it protect your data when in backup? Yes, because when you backup, the contents of the backup is still the encrypted text. It's not the plain text. So there's no way for them to, they can restore that, yes, but there's no way for them to unencrypt the data without the master key. So let's take a look. I have before I go there, someone asked last week about how do you do TDE on Azure SQL. The reason why I didn't go through with it when we did TDE is it's very easy to enable TDE for SQL database, because it's only a toggle here. You just need to toggle TDE here, and it's gonna create the certificate for you. It manages the certificate for you. You don't need to do anything. You just need to toggle this. That's why we didn't do a demo, because it's just a switch. You can go to the portal and then turn it on. All right, so let's take a look here. Let me just restore your database because I don't wanna. All right, let me change my connection. All right, so we have a database here named TDE demo. TDE demo 1. I have a table named employees. If you were with us on episode 1, this is the same table that we had. So we have a column here, NRIC, which is the sort of like the identification number for Singapore. So take a look here. Nancy and Andrew has the same NRIC. We're just gonna use it for demo. So first, let's create a new table. Let's create a new table for one for random and one for deterministic. You can have multiple columns with different encryption type for always encrypted. I just want to separate them on two tables so that we can take a look better. So it will have the same information as employees. All right, so it's the same table. Let's take a look at how the table looks. Because remember, by right, there's no schema changes for always encrypted. So we go here, for example, deterministic. Let's take a look at the table. So this is NRIC. This is the column that we want to encrypt. So currently it's nvarchar 9. Our database, let's see what's the collation for my database. It's the default collation, I think. So it's SQL Latin 1 General CP1 CIAS. So that means that's also the collation of the tables and the column. All right. So that's the table. You can enable always encrypted through SMS. It allows you to do that. There's a section here. If you go to security, always encrypted keys, here's your column master keys for this database, and these are the column encryption keys for your for this database. So right now there's no column master key here. You can see here the types of key store that are currently allowed. So we're Windows Certificate Store current user. What this means is it's when it creates the certificate, it will save it on the registry key for that current user. For example, right now I'm logging as my user PUB. So the certificate key will be on that profile, on the HK on the registry, HKey user. What that means is it's unique for my user. If, for example, there's another user who's going to use this PC, you won't be able to use that certificate. There's another certificate store called local machine if you want to store it on the registry key for the HK machine. So that means any user on this server will have access on that certificate, so he can read that certificate. Then Azure Key Vault, you just need to log into your Azure subscription. So I have here I have a key vault here. So if you haven't created one, you need to create first before you create a key here. and then you can generate a new key. These will be stored on your Azure Key Vault. And then the last option for a key store is a key storage provider, CNG. So that's a third-party one. But today I'm not gonna do it on SMS. I'm gonna show you how to do it on PowerShell for two reasons. Usually when you watch demos for AE, what they have is an app, or what they usually use to demo is a simple .NET application that you can enter your data. So in this demo, we're gonna do it on PowerShell because I wanna show you some information, some details that you won't be able to see if you do it if you do a whole application for it. Okay, let's first create. Let me clear this up. So let's first create the keys. If you look here, so I'm just gonna create a new self-signed certificate on my local key store. So it's current user, so it's my user. You need to have the SQL Server module if you're doing this, and then the server name and the database name. So I'm gonna create a column master key named TDE demo1 CMK, and then later after that we're gonna create a column encryption key named TDE demo1 CEK. So that's what the script is trying to do. Actually, if you're gonna do this in your environment, I advise doing it on PowerShell instead of SMS because it's a lot more. You have more control, and it's easier because here you need to pass the certificate to your when you create the column encryption key. You need to pass you see here, same case settings. I'm passing the thumbprint of my certificate. So let's do this. TDE demo1, TDE demo key. So let's go back to the Management Studio. Now we have here the master key and the encryption key TDE demo1 CEK. So the next step we're gonna do is we want to encrypt the column. So earlier I said we want to encrypt the NRIC. So let's go back here. To do that, you need to use the sets SQL column encryption, and this is one of the reasons why I'm doing it on PowerShell instead of SSMS. If you have an existing data, you cannot do in-place encryption for Always Encrypted if you're just using Always Encrypted, because it needs to remigrate your data out of the table and then migrate it back into the table. So it needs to pull it out to the client and then put it back in. So for PowerShell, it's using the client drivers for .NET framework, so it can do that. So here I'm importing the module, the server name, the database name, and then here is where I'm trying to encrypt. See here, DBO emp random NRIC, which is the column, and then emp deterministic NRIC. So those two columns you're gonna encrypt on those two different databases. You can have multiple encryption keys. You can have on a database, and you can have multiple master keys that encrypts those encryption key. It doesn't need to be one-to-one. But for simplicity, we're just gonna use one. So here it's going to encrypt the column. You see here, it's preparing the data. It's migrating the data out using the client driver and then migrating it back in. And trying to encrypt the data. Let's see. All right, it's done. If we go back now, and we select, remember we select emp random and deterministic earlier on. If we select the data now the data is already encrypted. I cannot see the value anymore. And then take a look here. The second table is deterministic. Let's take a look here. Remember, Nancy and Andrew has the same NRIC. Look here, the value for these two, since we're using deterministic, is the same. Let me see if I can zoom in for you. There you go. The value for the two is the same, exactly the same, because we're using deterministic for that table. And then let's take a look at the table. This is one of the reasons why I put an asterisk on the no schema changes. By right, there is no schema changes because you don't need to do anything. But if you go to the table itself, you can see here for always encrypted, the collation for the column changes. It needs to be in one of the binary to column encryption collation. So this is how you encrypt. This is the command if you want to encrypt using T-SQL. And here, like I said earlier, this is the algorithm being used by Always Encrypted. So you just change here if you want to change it to randomized or deterministic. So you can see there is a change in the table itself, but it's transparent to you. So that's the stable structure. And but how can I read it? Right? There's no way for me to read the data. But since this will only work because my master key is on the same server. By right, if you want to read the information, you need access to the encryption key. So I'm on the same machine, so I can do that. But you need to enable always encrypted connection. Later on, we're going to talk about Enclave attestation URL. But for always encrypted, you just need to enable this. For older versions of SMS, you just need to column encryption enabled. You need to add the parameter here. So enable always encrypted, then we can connect. Once we do that, we can view the data itself. So it's still encrypted. It still is stored encrypted on the server. But since my client connection is using encryption column enabled, so I'm using the drivers, the client drivers to decrypt my data. Will this work with Power BI? Yeah, Power BI uses .NET Framework 4.5, so it will be able to. Yeah, so how do we insert data, right? For always encrypted, let's see, let's try here. My connection is already using always encrypted on, right? But I won't be able to insert data. For always encrypted, hang on. I forgot to close my door. Sorry about that. Yeah, so you cannot insert data to the table through SMS because for always encrypted, you can only insert your data. It needs the information to be strongly typed. That means you need to specify the variable type of the column because it doesn't know. So what you usually do is you create a stored procedure to do your insert because stored procedure are parameterized, right? Either that or you enable parameterization on your server. So we will create this SP. It's nothing special. It's straight away insert. So we just specify the parameter, but okay, let's just take a look at here. So that's the SP we already created, but I'm using SMS. if I execute that, it's still gonna give me the error because, like I said, it needs to be strongly typed. Even if you specify the nvarchar, for example, here, we already declaring it as a variable. cannot you cannot manipulate your data using SMS because it's a backend tool. The only way for you to insert or modify your data is through the application. So still the same error. Let's go to Power BI, to PowerShell. Remember I said this one is using the client drivers. So it's the same. This is my application. If you see here, let me see if let me do this. Let's take a look at the data. Oh, sorry. Let me do that. Wait a minute. Let's do this first. So if I do this, we can read the data. You can see the NRIC because we're using column encryption setting equal to enabled. If we change that, if your connection doesn't specify the column encryption enabled, you won't be able to view the data. So you see here, what you will see is the encrypted format. You won't be able to see the plain text. So it's gonna be the same thing, even I'm already using a client driver here. I won't be able to insert values like this, just a plain ad hoc statement with an insert value, insert into command. If I do that, it will still give us the same error that we receive at the in SMS, even if we use the SP that we created. See here with the SPM deterministic. Even if that's the one that we use, we won't be able to insert. I know for the developers out there, this is not the right way of executing a command, but it's the same thing. It's just gonna pass the row inserted successfully if it's correct. So it's still the same thing. It will give you error. So for always encrypted, the data needs to be strongly typed. So if you look at here, it's gonna be the same if you do this on C# or any other programming language. You need to specify the variable. You see here, I'm building a SQL command as a new SQL command. So I'm adding the parameters here. For the other parameters, I don't need to specify anything, just the name and the parameter value. But for the encrypted column, you need to strongly type your column, the data type. So I need to specify what data type it is, and I need to specify the length because the database engine doesn't know the definition, right? Because it's encrypted. So what happens is it needs that information so that the client driver can rewrite the query to the correct command that it will pass to the SQL engine. So here, so once I hit F5, this section will be able to insert the information. I made a mistake earlier on. I hit F5. That's why you see one there. But if we do it again, there's gonna be two insert. So if we do this, let's see. Oh, we didn't change this. All right, let's try that again. So let's take a look at the other table. Oh, wait, sorry. again. All right, there. I forgot to uncomment the line. So you see here, it inserted. We now have two DBA Balistoy EO because I already clicked it twice. If I hit it again, it should be able to insert another line. And now you have three. So the only way to manipulate your data when you have AE is through your application. You won't be able to manipulate it through backend. That's the advantage of using AE. There is no way for you to change your data from the database itself. So let's go back to the slides. There are just some questions. Let me just address them. From Joaquim, any performance consideration if we use both TDE and always encrypted? I don't see the reason why you will need both. Usually what you do is you either use TDE or you use AE. It's already an overkill if you use TDE and AE. But in terms of performance impact, as we discussed last episode, right? The performance impact for TDE is very minimal. The last time they did the benchmarking is the change in performance of a TDE database to a non-TDE database is just around 3%, which is very minimal. So it doesn't really, it's negligible. But there I don't see a reason why you will need to enable both, since your data will already be encrypted. When you use AE, your important data is already encrypted. So what's the need for TDE? But good question. We can something to try. How can I restrict the user to add the connection parameter column encryption setting enabled? Because the encryption data become decrypted when I log in and add this parameter. Now remember, it's not just that. You need to have access to the master key for you to be able to decrypt. So if you want to restrict your user from being able to decrypt your data, don't give them access to your master key. Then even if they enable the connection parameter to column encryption setting to enable, they won't be able to read the data. And yes, the last question is, will this work with Power BI? As I mentioned earlier, Power BI uses .NET Framework 4.1, so 4.5, so it should be able to. All right, so going back. So in summary, where am I? Let me just go back to the slide. All right, so in summary, Always Encrypted encrypts your data in flight and at rest. Your decryption always happens on the client side, so there is a separation of roles. Your unencrypted data can only be viewed by your users from the application. Your database operators and database administrator doesn't have access to it. They cannot do that on the server itself. Yeah, so it can encrypt specific column just like cell level encryption. Column master key is stored outside the database. So if you want to restrict your user from being able to decrypt your information, don't give them access to your master key. Separation of roles, like I said, your DBA doesn't have access to your data. And you have two types of encryption, deterministic and randomized. Deterministic allows, oh, did I show you guys that? Let me just go back. We can still take a look at that. We still have time. If you look here, the random, this is the one that we encrypt using random. You won't be able to use group by. But here, deterministic, since the values are the same for the same values, it will be able to do a group by. For deterministic simple equality operation, it can do it. It can do simple equality operation. Random, you cannot do anything. Indexes, non-clustered indexes, you can also do that for deterministic, but not for random, because it cannot, there's no point. All the data is different. So going back to our summary. So, but what if I want complex computation and operations for my encrypted data? So as we've shown, even group by, right? You cannot do group by for randomize. Any equality operation you cannot, any comparison you cannot do, any computation you cannot do. You have to pull the data out from the database to put it on your client and do your computation on the application layer, which is a very big disadvantage for AE, because those computation the computation on the application layer is very limited. That's where so you see here, you need to bring your data out, bring it here to plain text before you can do any operation, any comparison, any grouping, any computation on your data. For example, even if it's an integer value or a decimal value, you need to convert it to plain text before you do computation. You won't be able to do it on the SQL server, which is a very big disadvantage. That's where Secure Enclave comes in. Secure Enclave allows you to have a protected portion on the SQL Server memory on your server, on your database engine, wherein you can do your computation. So here, what it does is it allows you to it allows the client driver to check. It will check, do we have a secure enclave on this server? If it does, it can go ahead and decrypt the encryption key, pass it to the secure enclave. This is a secure channel. It's a black box. Any SQL Server processes doesn't have any information on what's happening on that portion of memory. It's a secure area on your memory that the unencrypted data can live. So even like I said, even the SQL Server processes, they won't be able to view what's happening on the secure enclave. Even if you use a debugger, the information won't be readable. So that's the secure enclave. Then once your plain text is on your enclave, you can do your computation. You can do in-place encryption and other rich computation that you require. When we say in-place encryption, remember earlier when we encrypt that table, because there's an existing information, it needs to remigrate the data. For always encrypted, you cannot, as I said earlier, you cannot do that using SMS because it's not pulling the data out because there's no client. So for secure enclave, you can do in-place encryption. You can manipulate your data within the secure enclave. And do, for example, if you want to re-encrypt your data using a new master key, you can do that on the server. There's no need to pull the data to the client. If you want to do rich computation, that's what Secure Enclave allows you to do. When you enable Secure Enclave, you can do equality operation on your randomized encrypted column. You can do more equality joins and comparison on your deterministic encrypted column. So that's what Secure Enclave gives you. Now, for you to have a Secure Enclave, it depends on your hardware, because it requires you to have a host guardian service. This service is the one that does the attestation on that area of your memory. It's the one that verifies the certificate and say, yeah, it has the certificate. You can encrypt this portion of memory for me, and then that's the one that handles that encryption. If we see here, remember earlier when we do the connection, if we have a secure enclave here, I don't have secure enclave because you need to configure HGS, and it's you need to have a data center edition of the server. It only runs on Windows SQL Server, Windows Server 2016 and 2019. HGS service only runs on that OS. So if we go here, you see here the enclave attestation URL. Once you enable HGS service, it will create a URL for you, like that's the one that will verify your certificate, check your certificate, and then grants you that space in the memory for you to process your query. So that, like I said earlier, that portion of memory is not accessible to any other process on the server and from the SQL Server processes. It's reserved for secure enclave for the encryption. And a few other items that you need to enable when you do secure enclave. Let's go back. So you need to specify this is a SP configure parameter, column encryption enclave type. You need to enable that. You need to enable trace on trace flag 127 if you want to do rich computation. And then when you create your master key, you need to specify enclave computation for it to be able to do secure enclave, for you to be able to use it for secure enclave. And with that, I right on time, 7:51. Do you have any questions? Let me just check. I wish I could demo secure enclave, but since it's I didn't know that I'm gonna do this this session today. I only found out that last week, so I wasn't able to configure a server that we can use it. And do we have any question? Aside from the one in the chat. Is it something that you think you can use in your production environment right now? No question. All right. It looks like there's no question. Oh, wait. So once the master key has been created, if they miss out on applying enclave, they have no chance. Yeah, you have to recreate your either create a new master key. Remember I said earlier, you can have multiple master key for one database. You can have multiple encryption key. You can even have multiple master key that it encrypts a certain encryption key. So if, for example, you want to use secure enclave, you need to create a new master key and then re-encrypt your encryption key. That's what that's one of the things that you can do with in-place encryption. You can rotate master key. By right, if you want to create a secure environment, right, you should have a process for rotating your keys. So you shouldn't be using one key for the entirety of the project. For example, since 2011, this is the same key that we've been using. No, it's not secure like that. You need to rotate your keys periodically. So yeah, you can re-encrypt your column using a new master key with secure enclave enable for you to be able to reuse for you to be able to use secure enclave, which is the same thing for example, you have existing environment right now that has always encrypted already enabled. So if you, for example, you migrate to 2019, then you can enable secure enclave. Just create a new master key for it. All right. So if there's no more question, then thank you everyone. If you guys can drop an evaluation, you can use the link here, or you can scan the QR code or use the link. I can message the link on the chat. Let me just see. So we can rotate the key without decrypt and re-encrypt again. Invisible? No, not really invisible to the DBA. You need to when you rotate your key, right? You need to re-encrypt your column encryption key. So you need to, well, it depends on who's doing your rotation, but usually that's the DBA. So he'll know that you change your keys. All right, so I'll give you guys, well, if the PII, oh, there's more question. If the PII data in the DBA will temporarily have visibility, no, because the when rotating the key, no, when you rotate, remember earlier when we do the re-encrypt, it doesn't output the data, so there's no way for me to see it. Remember when we did this on the, where is it? When we did this part, it didn't output the, when you do encryption, it doesn't show you the data itself. It just shows you that you're migrating the data in and out, but you won't be able to see the actual data. So there, it won't be visible for your DBA. No, remember the encryption and decryption happen on your client key. There's a question on the chat. When you rotate your keys, what is the data in any time visible to your DBA unencrypted? No, because it needs to be unencrypted on your client side. So when we do the encryption on the column, there's no, the data itself, you won't be able to see. If you go to the back end, if for example you're rotating the key, that means the data itself is encrypted already. So when you go to the table, it's still encrypted. And then when it's re-encrypted with the new key, the values will just be different, but you won't be able to see the plain text data. It's still going to be the new cipher data. So there is no gap wherein your database admin will be able to see the plain text data. You still need the application if you want to see the plain text, or if he has access to your old master key. And well, if you put it that way, right, then it's gonna be a trust issue if he's gonna use that to unencrypt your data. But yeah, the process itself, you won't be able to see the data. But what he does in between that, I won't be able to say, right? Right. All right. So yeah, we're just in time.